Respected sir, my name is Tulsi Saimunangi of 19th batch of MTech Integrated Software Engineering. Apart from digital assignment 2 of information and security system, I'm going to tell about RSA algorithm. And these are the content. Today I'm going to discuss about brief about the introduction, features, characteristics, steps for RSA algorithm, example, and advantages and disadvantages of RSA algorithm. Coming to introduction, RSA algorithm was invented by Devesh, Shamir, and Edman of in the year 1978. It is best known and widely used for public key scheme. Uses large integers, example 1024 bits, based on exponential in a finite field over integers modulo a prime. Plain text is encrypted in blocks, with each block having the binary value less than some number n. Security due to cost of factoring having large numbers. So coming to RSA algorithm is an asymmetric cryptography algorithm. Asymmetric means actually that it works on two different keys, that is a public key and as well as a private key. As the name describes that public key is given to everyone and private key is kept private. Now coming to the features of RSA algorithm. The RSA algorithm holds the following features. The RSA algorithm is a popular exponential in a finite field over integers, including prime numbers. The integers used by this method are sufficiently large, making it difficult to solve. There are two sets of keys in this algorithm. As I have already told, they are having private key and public key. Private key means in the name instant it will keep that private, and the public key is given to everyone. Coming to the working principle of RSA algorithm, it works on two keys. Coming to those two keys are of public key and then the other one is private key. Coming to public key, it comprises of two numbers in which one number is a result of the product of two large prime numbers. This key is provided to all the users. And coming to the private key, which is the second part, it is derived from the two prime numbers involved in public and it always remains private. Coming to the working diagrammatic presentation of RSA, here we can see there is a sender and receiver and the communication channels between plain text, between the ciphertext of encryption and decryption. So this is the working diagram of RSA algorithm we can see in the presentation. Coming to the characteristics of RSA, it is a public key encryption technique. It is safe for exchange of data over internet. It maintains confidentiality of the data, and the RSA has high toughness as breaking into keys by interceptors is very difficult. So now I have discussed the four characteristics of RSA. That is, it is a public key encryption technique, and it is safe for exchange over data in the internet, and it maintains confidentiality and integrity of the data, and it has high toughness as breaking into keys by intercept is very difficult. Now, I'm going to discuss about brief steps involved for RSA algorithm. There are nearly 4 steps which consist of key generation technique, and the 6th and 7th step is about the communication of encryption and decryption. So, coming to the first step of RSA algorithm, the first step is of generate the RSA module. That is RSA module. That is, the initial procedure begins with selection of two prime numbers, namely those are of P and Q, and then calculating their product N. As shown in this box, there we will be selecting two prime numbers. Like let us take P of sum of the number and Q equal to sum of the number. So which will be represented by N. So N equal to P into Q. Let N be the specified large number. So for the first step, we will be generating the key. So the formula is N equal to P into Q. P and Q are the prime numbers. Coming to the second step, that is derived number E. So consider number E as a derived number which should be greater than 1 and less than P minus 1 and Q minus 1. The primary condition will be that there should be no common factor of P minus 1 and Q minus 1 except 1. So the second step itself, it says that derived number. So we will be taking P minus 1 and Q minus 1. So we already know that P and Q are the prime numbers. We will be taking the first step. So M equal to P minus 1 and Q minus 1. So this is the formula for the second step. The first step is about we'll be taking about two prime numbers of n equal to p into q. So in the second step, m equal to psi of n equal to p minus 1 and q minus 1. Coming to the third step implies about the public key. So I have already thought that public key means everyone. So the specified pair of numbers n and e forms the RSA public key and it is made public. Select an integer e such that e is a coprime to psi of n and 1 less than e less than of psi of n. The pair of numbers n of n comma e makes up the public key. So the third step implies after we have find the value of m in the second step, that is p minus 1 and q minus 1. So now we will be knowing about the third step. The third step implies about the public key. The condition for the third step is 1 less than e less than psi of n. So e should be less than 1 and psi of n. Note 2, here we have to note the condition that two integers are coprime if the only positive integer that divides them is 1. So this is the note point of the third step. So after finding the e value, that the condition given here, we will be finding the fourth step of private key. So the private key D is calculated from the number P, Q and E. The mathematical relation between the number is as follows. E into D equal to 1 mod of psi of n. We know n means psi of n equal to p minus 1 and q minus 1. So D can be found using the extended Euclidean algorithm. The pair n comma D make up the private key. So for the first step of private key, E dot D equal to 1 mod of psi of n. 1 mod into psi of n. Coming to the fifth step. So in the both fifth and sixth step, we will be dealing with the communication that is of encryption and decryption. They will be holding two steps in the fifth and sixth step, that is about encryption and decryption. Coming to the encryption part, consider a sender who sends the plain text message to someone whose public key is n comma e. To encrypt the plain text message in the given scenario, use the following syntax. C equal to P power E mod N. So encryption formula, after finding those all things, we will be going for encryption. We will be getting the value of encryption of C. So this is the cipher text, C equal to P power E mod N. The formula is C equal to P power E mod N. Coming to the last step of RSA algorithm, that is about decryption. The decryption process is very straightforward and it includes analytics for calculation in a systematic approach. Considering receiver C has a private key T, the result modulus will be calculated as. So after finding the ciphertext in the encryption, now we will be finding the decryption. So P equal to C power D mod N. We will be finding the C value in the before step of encryption. Now we will be finding the decryption value. So P equal to C power D mod N. So coming up with an example of RSA algorithm, now I'll be explaining the example with stepwise procedure. First step is about key generation. So in the key generation technique, we will be taking two large numbers of a prime number, that is P and Q. Let us name that as P and Q. So the formula of the first step is about capital N equal to P into Q. Let us take P equal to 7 and Q equal to so after we have taken the two prime numbers of P and Q of P equal to 7 and Q equal to 19. Now we will be going to the next step of the second step called derived number E. So we know the formula of derived number E, that is N equal to P into Q. So we know the values of P and q. So p equal to 7 into 19, that is equal to n equal to 133. So now in step 3 we will be finding the value of m. So let m equal to p minus 1 into q minus 1. M equal to 7 minus 1 equal to 7 minus 1 to p minus 1. The answer equal to m equal to 6 into 18 equal to m equal to. So in the first step, we have taken the two large prime numbers, that is n equal to 7 and q equal to 19. In the second step, we will be finding the derived number e, that we will be multiplying n equal to p into q, that is 7 into 19 equal to 133. We have find the value of n, capital N. Now in the third step, we will be finding the value of m. So the formula is m equal to p minus 1 into q minus 1. So the answer we got for m equal to 108. So we have find three steps in this slide for the Rsa algorithm. So after finding the step of 1, 2, 3, now we will be going to the first step. The first step is about choose a small number e co-prime to m. So GCD, we know the GCD step. So the GCD of psi of n comma e should be equal to 1. So e should be co-prime to m means that the largest number that can exactly divide both e and m, that is equal to 1. Euclidean algorithm is used to find the GCD of two numbers. Now we will be finding the value of e. So the value of e should be psi of n comma e should be psi of n of e should be equal to 1. So we will be finding we will be assuming the values, let us take 2. So it will not be considered. Again 3, not equal to 1. Again 4, not equal to 1. By taking the value of 5, that is GCD of 108 dot e of 5 equal to 1. So we will be selecting the value of 5 for e. So after finding the value of e, now we will be calculating the value of find the value of d such that de mod of n equal to 1. So for that we will be this is equivalent to finding d, which satisfies d equal to 1 plus am, where k is any integer. We can rewrite this as d equal to 1 plus km by e. Now we work through values of k until an integer solution for e is found. So now same as in the before formula, now we will be assuming the values to find the value of k that should be equivalent. So we will be taking as k equal to 3, that is d equal to 325 by 5 equal to 65. After finding the value of d, we have got the values like public key equal to n equal to 133 by e. We know that public key equal to n comma e and secret key equal to m comma d. So we have find the public key value n and e, that is 133 and 5, and secret key of m and d, that is m equal to 108 and d equal to 5. Now we will be finding the final step of communication, that is the encryption and decryption. Coming to the encryption, the message must be a number less than the smaller of p and q. However, at this point, we don't know P or Q. So in practice, a lower bound on P and Q must be published. This can be somewhat below their true value and so isn't a major security concern. For this example, let us message be 6. So the formula is C equal to m power e mod n. So C equal to 65 mod 133. C equal to 776 mod 133. So C equal to 62. We have find the encryption value. So encryption value of ciphertext equal to C equal to 62. Now coming to the decryption. Decryption. This works very much like encryption, but involves a larger exponential, which is breakdown into several steps. So the formula is a message equal to cipher power D mod n. So 62 power 65 mod 133. That is the value equal to 6. So this is the example for an RSA algorithm, which we will be dealing the 7 steps. For the first step, we will be going for key generation and derived equation of E. And then we will be dealing with the communication of encryption and decryption values. Coming to the advantages of RSA algorithm, it is very easy to implement RSA algorithm. RSA algorithm is safe and secure for transmitting confidential data. Cracking RSA algorithm is very difficult as it involves complex mathematics. Sharing public key to user is easy. Coming to the disadvantages of RSA algorithm, it may fail sometimes because for complete encryption, both symmetric and asymmetric encryption is required, and RSA uses symmetric encryption only. It has slow data transfer rate due to large number involved. It requires third party to verify the reliability of public keys sometime. High processing is required at receiver end for decryption. So in the presentation which I have given, I have said about the advantages and disadvantages and the steps involved in RSA algorithm, uh, as well as the explanation of the problem. Thank you, sir.